The concept of this video is about factoring quadratics, specifically when the quadratic has a starting value of 1, when a is 1. So just as a reminder, you were doing these diamond problems. They were set up in this structure over here on the left, where you had originally two numbers that you saw on the side, here and here, and then hopefully you figured out what the top and the bottom numbers started to mean. So essentially, if we named these numbers instead of like a number sign, let's say we named them x and y, when you did this, the top number represented what x times y is, and the bottom number represented what x plus y is. And this idea, this is factoring. This is the whole idea between taking a standard form quadratic and turning it into a factored form quadratic. And this only works when the x-intercepts are integers. So if the x-intercepts are decimals, we would not write it in factored form. We would not be able to do this. But essentially, you were coming up with, well, actually throughout the whole diamond process, sometimes you were coming up with the top and bottom box, or the two left boxes, the two right boxes, and then eventually you were coming up with these two boxes, the x and y boxes, and that's factoring. That's how this works. So as I go through these examples, you'll see me fill in the top box here and the bottom box here, based on the quadratic, and you will be determining what x and y are. So if we look at one, let's say x squared plus 8x plus 12, one thing you have to know is, well, which one of these numbers, 8 or 12, is the one where you're multiplying and which one is where you're adding. This 8 is the x plus y box, so that would go at the bottom, and this 12 is the x times y box here. Okay, so from there, you're going to be doing the exact same thing you were doing with the diamond problems. Well, what factors of 12 add up to 8? Okay, what factors of 12 add to 8? Well, if you think about this, if I write down my factors of 12, just to break this down for those that were maybe struggling with this, these are all the ways I can get 12, right? 1 and 12, they don't make 8. 2 and 6, that makes 8. 3 and 4 don't make 8. So this 2 and 6 would go here, and then this line is what you use for factored form. So you would write x plus 2, x plus 6. And just to prove that to you, if I were to, let's say, box it up, right? If I were to box this, just to show you that it does work, you get back to the same thing, you can. X plus 2, x plus 6, this is x squared, 6x, 2x and 12, and 6 plus 2 is 8, so x squared plus 8x plus 12. Notice how you get back to the exact same thing. So again, you're going to take this middle number and put it at the bottom, negative 8. You're going to take this end number, put it at the top. So this is really factors of negative 20 that add to negative 8, right? So if I think of this, factors of negative 20, well, 20 has 1 and 20, 2 and 10, 4 and 5. Okay, so I think it's going to be 2 and 10, but there's going to be a positive and a negative. I need negative 8. So I'm going to do 2 plus a negative 10 would give me negative 8. So these are my two factors. So when I write this, x plus 2, x minus 10, this is my factored form right there. Last practice one. So again, 12 goes at the bottom, negative 13 goes at the top. So factors of negative 13 that add to 12. So 13 is a prime number, it only is 1 and 13. So if I want that to equal 12, and I know I'm adding, the only thing that can make that work is if 1 is negative. So negative 1 and 13, so x minus 1, x plus 13, factored form, okay? So I hope this kind of gives you a little insight into how to try some of these factored forms. It does get harder if you don't know your factors of your numbers, but this is a good starting point. Always let me know if you have any questions.